Yeah. So 1.6 is our last section from chapter 1. There we go. And we start looking at this concept of absolute value. So it's something you've been introduced before. Who can tell me what is the definition of an absolute value?
How far away a number is.
From where? How far a number away is from
the number that's in the box.
From 0. So it's just always going to be how far that number is from 0, which is going to cause us to, we're going to have to kind of think of both sides of 0. So we got to think, okay, how far is it on this side? How far would the number be on this side? So for example, if you had just a simple equation, absolute value of x is 5. What that's telling us is, what number could x be so that it is 5 units from 0? So the obvious answer is what? 5. So one of our answers, x could equal 5. But there's actually two numbers that are 5 away from 0. Negative 5. So on the negative side, we could also have that result be 5 units away from 0. Now you could present your answers as 5, negative 5. You also might see it written like that, x is equal to plus or minus 5. So we just have a plain absolute value of x. If absolute value of x has to equal 5, that's going to leave us with two options. X could equal a positive 5, or x could equal a negative 5. So when we start looking at solving our equations, we have to think about both possibilities. We have to think about both sides of 0. So when we get to a problem like number 1, we've got our unknown t plus 5 in absolute value needs to equal 8. We're kind of using that same pattern then. What this is asking is your t plus 5 could equal plus or minus 8. Could equal either one. Because if it equals the negative 8, is that 8 away from 0? No. Yeah, that works. If it equals positive 8, that's also 8 away from 0. What it causes us to have to do is we have to set up two separate equations. So t plus 5 could equal 8. T plus 5 could equal negative 8. And do some simple algebra. T could equal 3. And t could equal negative 13. So we're just using simple one-step algebra. There's going to be our two solutions. Now, biggest mistake I see is everybody likes to first solve the positive answer. Yep, t plus 3 equals 8. T plus 5 equals 8, so I get 3. Well, that must mean my other answer is negative 3. It's got to be plus and minus. That's not really the case. That's not always going to be the case. Sometimes that's the way it happens. Like if we have a simple equation like this. But I have to account for it could be plus or minus 8, and then when I start setting up my equation, we're going to get those two results. So don't just rest on finding one answer and then just saying automatically, oh, the other answer must be negative 3. That's not always going to be true, and you can throw back each of those numbers in for t and check to see if they both work, and you should see that one doesn't work if you do that. But we get t equals 3. We could check our answer, which with absolute value you always want to. I know when I was a student, I didn't check my answers very much. And I kind of noticed that it's kind of a common thing. Sometimes you get done with the problem and you just get excited and like, all right, I'm done. I'm just going to move on. I don't want to worry about it. Well, with absolute value, when you get two answers, we're going to want to check because later on we'll start looking at extraneous solutions when we get those types of solutions as well. So 3 plus 5 is 8, perfect. Negative 13 plus 5, negative 8, that's 8 away from 0, we're perfect. Number 2, just really quick, we're not going to solve completely, but number 2, there are cases where you're going to have extra numbers around your absolute value. We can't make our equations until we get to the point where absolute value is alone. Like on number 2, we do have to get rid of that 3 that's up in front. So 3 right now is multiplying my absolute value, so I'm going to do the inverse of multiplying. I would divide, which is going to give me z plus 7 equals 4. Now I'm ready to set up my two equations. Z plus 7 could equal 4. Z plus 7 could equal negative 4. So there I have my two separate equations. After I get that absolute value alone, now I'm ready to start checking both sides of 0. So it could equal 4, or it could equal negative 4. You guys okay if I erase those two problems? So we're going to head down then and look at the second part where we can get what are called extraneous solutions. So we want to check our answers every time because sometimes we get these extraneous solutions. And extraneous isn't a word that we use in everyday language very much. So what you can think of extraneous as is it's like a false solution. I don't know how much you guys pay attention to the news and stuff, but there's been a lot of false positive tests with testing for the virus and things. So this is kind of like where we get a result, we solve it out perfectly, we get an answer, we put it back in and it doesn't work. It's like a false solution. It doesn't actually work back in the original problem. When we set up our absolute value equation, we're going to still stick to the pattern that we looked at. So if I have x plus 5, so I'm looking at the absolute value of x plus 5, I'm looking for a distance. This number is from 0. And based on what we talked about above, we have a distance that could be on the positive side of 0, or for you guys, the positive side would be over here, or on the negative side of 0. So when I set up my two equations, I'm going to have x plus 5 could equal the positive version of 3x minus 7. And then also x plus 5 could equal the negative version. I'm going to kind of go over to the next problem a little bit, which would be negative 3x plus 7. So I'm just taking that 3x minus 7 and I'm going to change both of those to their opposites, because now we're looking at the negative version of that. So I'm following that same pattern. The absolute value of 5 could be a positive 5 or negative 5. They're both 5 away from 0. So here, if my absolute value needs to equal 3x minus 7, I'm going to look at the positive version of 3x minus 7. And I'm going to look at the negative version of 3x minus 7, which is negative 3x plus 7. Do our algebra. We'll get the x's collected on the right. That's going to give us 2x. Subtract x over, add the 7 over, that gives us 12. So we're going to get x equals 6. There's our result on that side. I'm going to add the 3x over to make 4x on the right, or sorry, the left. Subtract 5 over, we get 2. Divide by 4. X will equal 1/2. So there would be our two solutions. Now we got to check, are one of those solutions false? Sometimes one of them's false. One will always be true. We got to have one solution. Sometimes one of them are false. Sometimes they're both true. We just have to check. So let's start with the 6. 6 goes into this x. 6 plus 5 would give us 11. Absolute value of 11 is still 11. That one's good. That's what we get on the left side. 3 times 6, 18, take away 7, 11. 11 equal 11? Perfect. So that is the solution. I'm just going to put a green check mark next to it. There's that one. Over here, 1/2. So 1/2 plus 5 would give me 5.5. You guys agree with that? How far is 5.5 from 0? 5.5. Okay, so that's positive 5.5 on the left side. Here, this is going to be 1.5. Take away 7, that's going to bring you down negative 5.5. So does 1/2 work? No. So we're just going to cross that answer out. Or some people are asking, can I just say extraneous next to it? Yep, you can just put extraneous next to it, cross it out. But this one only technically has one solution. So there would be our answer, 6. So for each absolute value, you're going to want to go back and check, does each solution work? Because sometimes I could get a fake solution for some of my answers. As you practice more, we don't have a ton of practice problems, but you start to recognize the pattern of when you have an extraneous solution, when you don't. Your only possible time you'll have extraneous solutions is when you have variables on both sides.
You ever have variables on both sides? That's when we start to see.
those extraneous. So like number 6, possibility I could have extraneous on this one. You look at this one, is there a variable on the right? No, so this one will have two answers that are true. So both of those will work whenever you solve those two out. So that's basically it for equations, just kind of making sure we account for both the positive and the negative. You guys okay if I delete that up there? All right. So lastly, then we'll start looking at these absolute value inequalities. And we'll start to kind of find a pattern like we did with the equation. All these math things follow patterns. Hello, you got some copies for me?
Yeah, for your homeroom though.
Oh,
I don't know exactly what it's for, but there's some.
Guide. Okay. Oh, yep. All right.
Yeah.
Thank you.
Yeah, no problem.
Oh, yeah. Yep. Gotta sign up for stuff. All right. So the second part of absolute values, we can start to look at inequalities. So I'll present the same problem to you that we had above, just change it a little bit. Absolute value of x less than 5. So in layman's terms, what this is saying is the distance from 0 has to be less than 5. So who can tell me what's an example of a solution that would work for this problem? What solution for x would work?
X is greater than -5.
Okay, so you're going right to the solution. How about just give me a number?
2.
4, 2,
4.9.
4.9. Any others? Negative 4.9. Okay, right away our brains kind of went to the positive version. So in general, if we just get rid of the absolute value and we just look at this inequality, x has to be less than 5. Because those numbers, 4.9, 4, 2, 1, those numbers would be closer than 5 to 0. So we have to have our distance be less than 5. But eventually you start going -1, -2, -3, -4, -5, -6. How about -6? Is that less than 5 from 0? No. So at some point we got to cut it off. I think that's what you were looking at. So what other part or what other inequality do we need to include to keep our numbers less than 5 from 0?
X greater than -5.
There it is. So x also has to be greater than -5. There's our two situations. So if I keep x less than 5, that's going to keep those positive numbers closer than 5 to 0. But at some point, it's going to start getting further away than 5 from on the negative side, so I have to make sure x is greater than -5. Take a close look at that second inequality. So first, this inequality, x less than 5, we just took the exact inequality, took off the absolute value symbol. What happened to my inequality in this second one I wrote? Flipped it. How about my number I'm comparing it to? Just changed to its opposite. So it's just going to follow that type of pattern. A little bit more about this type of inequality. This type of inequality is called a conjunction. That word is it's also used in other subjects like English, but we're going to call it an and inequality. So x has to be less than 5, and x has to be greater than -5. And conjunctions can be written as a compound inequality. So another way I could write this is that -5 has to be less than x has to be less than 5. So we kind of have that range of values. And lastly, we'll be graphing these conjunctions. X is greater than -5, x is less than 5, so our range of values would be anywhere from -5 to 5 is what we're looking at. Over on the left, I'm just going to look at a disjunction. So a disjunction is when we have this. Oops. Absolute value of x has to be greater than 5. So the distance that a number is from 0 has to be greater than 5. So who can give me just a single number? What's the number that has a distance greater than 5 from 0? 6, 7, 8, okay, so on and so forth. So you're telling me these solutions. X is greater than 5. But what other numbers? We just did the positive ones. What other numbers are greater than 5 from 0? Negative 5.1. What else? 9. Negative 942. All those numbers. So on this side of things, on the negative side, x has to be less than negative 5. But look at the pattern. My first situation represents exactly what the absolute value originally was. Absolute value inequality, except I just took the absolute value symbol out. Then what do I do with my sign? Flip it, number, change it to its opposite. So this one is called a disjunction, but most commonly we refer to this one as an or. So it could be one or the other. And when you graph it, you'll see a disconnection. That's kind of why it's called a disjunction. I'm getting a little small there, but you're negative 5 and less, 5 and greater. So it's a disconnected, your graph solutions are going to have kind of a gap in the middle where there are no solutions. So the numbers from negative 4.9 to positive 4.9, none of those are going to be true in that inequality. So if we head down to number 8, we can't quite apply the absolute value until we get rid of this 5, so we'll divide the 5 out. We'll be left with y plus 3 is less than 5.
Oh, yeah.
So I can undo this times by 5. I'll divide that 5 off. So to undo that, and then 15 divided by 5 should give me 3. You're right. Thank you for catching that. Screwed up on my math facts. Helping my daughters in 4th grade, I should know all that. 15 divided by 5 would be 3, not 5. So yes, at this point. Now at this point, you can kind of tell if it's going to be an and or an or. So anytime your variable side is less than, we're looking at this conjunction and. So when we graph this, we're going to see the two solutions meeting each other. So we're going to have a range of solutions in our problem. So we'll set up both situations. Y plus 3 is less than 3. Y plus 3 greater than negative 3. So if you're wondering what I did there, again, I just wrote one of my inequalities exactly the same as the absolute value. Just took the absolute value off. Second one, I flipped the sign and compared it to negative 3. So negative 3. So y is less than 0. And subtract 3, subtract 3. Y is greater than negative 6. And when we look at a graph of that, that's 0, that's negative 6. Y is less than 0, that's going to go negative. Y is greater than negative 6. There's going to be our graph of our solutions. One other thing about these conjunctions is you can write them as a combined inequality. So we have a negative 6 is less than y is less than 0. So you kind of show that range using a combined inequality. Disjunctions, we can't do that because there's just two separate situations that are happening, but here we can show the range. It goes from negative 6 to 0. There's where all our solutions are going to lie. We want to make a little note, number 9. Once you add that 3 over, this one will be a disjunction, so you should see your arrows going apart. This one, I'll do a little bit of algebra, add the 5 over, divide by 2. And since it's less than, this one will be a conjunction, or an and. So number 9 will be an or. You'll see them going apart. Number 10 will be a and. You should see them graph together. All right, we'll finish up looking at number 11 real quick, how to write an absolute value inequality from a little story problem down there. So let's take a look at that. Am I okay to erase this one? All right. And I'm recording all this, so if you want to go back and get a screenshot. All right, problem 11. We're going to take a range of values and we're going to write out an inequality, absolute value inequality to represent that. So like that last problem, we found the range was 0 to 6. And we can start to graph out what that range of values will be. Well, this time, we're going to be given a range of values. And then what we have to do is we have to write an inequality that represents that. So it says to become a potential volunteer listed in the National Marrow Donor Program registry, a person must be between the ages of 18 and 60. Let A represent the age of the person in the registry. So basically, here's what we're looking at. 18 has to be less than or equal to A, has to be less than or equal to 60. So we're looking at that range of values. So we want to go back now and write an inequality representing that. Well, first thing that we're going to need to know is we're going to need to know where is the middle of this range. So if I know 18 is the low end, if I know 60 is the high end, what could I do to find the middle number? Add them up and what? Divide by 2, otherwise known as finding the what? The average. So we're going to find the average or the mean. Once we know the mean, we kind of know where that middle ground is. Where's the mean age for these people? So 1860, that's going to add up to 78. What's 78 divided by 2? 39. The next thing that we're going to need to find is the tolerance. So what age of people is tolerated? So tolerance is like what's like the limit of people that are tolerated. So to find the tolerance, there's a couple ways to do it, but a really quick, easy formula to find the tolerance is to take the max minus the min divided by 2. So if you take the 60 minus 18, that gives you 42. And then what's 42 divided by 2? 21. That's going to be my tolerance. So all this means is that from 39, the mean, I tolerate people 21 years older than that. And I also tolerate people that are 21 years younger than that. Because what's going to happen when you take 39 plus 21? 60, that's the max age. How about 39 minus 21? 18. So I've got my tolerance. So now I'm going to start to look at creating my absolute value inequality. To find that absolute value inequality, it's going to be a conjunction, and it's going to follow this model. A minus the mean has to always stay less than or equal to the tolerance. So we're going to have A minus, our mean was 39, has to stay less than or equal to 21. So you put in an age. Let's say we put in a 21-year-old. No, let's do 25-year-old. 25. So 25 goes in for A. 25 minus 39? Negative 14. Is that within the tolerance? Yeah. Yes, it's less. It's going to be less than 21 from 0. You put in a 75-year-old. 75 minus 39? 36. 36 within that tolerance? No, you're outside. So you have an absolute value inequality that's going to solve out, find out what your age is compared to the mean, and then find out is that within that 21-year tolerance that we have. So I'm going to have you try number 12. Just to kind of remind you, you're going to want to make sure on number 12 you find the mean, and then also find the tolerance. And let's just put the formulas for that. So the mean is going to be the max plus the min divided by 2. Tolerance is your max minus the min divided by 2. So there's what you're going to look for on number 12. You're also going to want to look at this carefully. If you have 228 below sea level, negative number. So just keep an eye on that. That's enough of me talking. I wanted to give you a little more time. You got about 10 minutes to continue working on 1.6. So hopefully that kind of gives you a good head start, and then you can just kind of finish up those last couple problems. But tomorrow, just check the schedule. So for any updates on that, you'll just be for sure making that Delta Math account at some point tomorrow, and then check for any other updates in class. All right, the rest of the time then is for you. I'll be tinkering around up here with this video, and then I'll come around to help out here in just a second.